Here's another one from 7.2. This is in the problem set number 13, 7.2, section 3. Couple things here. The first is, notice that our conclusion is M, and M shows up nowhere in the premises. If it's nowhere in the premises, the only place we can get it is by addition. Now also, because our conclusion doesn't show up in any of the premises and we have to get M, what that means is the only way to do that is if there's a contradiction in the premises. Contradictions, you might remember from reading, can be used to conclude anything. They can be used to justify. Contradictory premises are always going to make a valid argument because it's never possible to have all the premises true and the conclusion false. If two premises contradict each other, all the premises cannot be true. So here's how this one's going to go. Let's see. A lot of different ways we can go about it, and remember, when you don't know what to do, you just do something. Use one of the rules and apply it legitimately. First thing I'm going to do is simplify D out of this third premise. Remember that in an AND statement, they're both true, and if they're both true, we can conclude one of them. So if D is true, that's the opposite of this consequent. So by modus tollens, right, we have an if-then statement. Since this consequent is denied down here, we can conclude that G must be false. Okay, what else can we do here? Well, let's see. If D is true, like we decided, then we can add or E to it so that we have the antecedent here, and then by modus ponens, we can get the consequent. I know it's kind of weird when I use all those technical terms, but that's just how it works. The idea is that we could get this by itself, but we have to have this whole statement. We don't have D or E anywhere. We do have D. Because D is true, we know that the statement D or E is true. And that is the addition rule. We can add the or E to it. And that comes from line 4. We added the E. So far, so good, I hope. Now that we have D or E, that's the antecedent here, so we can conclude the conclusion, G and H. From lines 1 and 6, modus ponens. Modus ponens, if-then statement, if you have the antecedent as true, then you can conclude the consequent is true. Just going to simplify G out of our AND statement. And now you'll notice 5 says G is false, 8 says G is true. So we have a contradiction in our premises, yeah. So in order to get M, I'm going to say G or M. How did I get that? How in the world can you just throw on an or M? If you said addition, then you're paying attention. This would be from line 8, we added. And now it's nice and easy, nice disjunctive syllogism. We want to get M by itself, but we just added it and it's stuck in this G or M. If we knew that G was false, then by disjunctive syllogism we could conclude M. And we do know that G is false. Line 5 tells us that G is false. 5 and 9, disjunctive syllogism. That's it. There's our conclusion. Now remember, this letter didn't show up in the premises, so we knew we had to add it somewhere along the line. And if the conclusion is only stuff that didn't show up in the premises, it has to be based on some contradiction. A little bit sneaky, that's Hurley. That's how logic works. And sometimes they are a little bit sneaky like this, where if you get a contradiction, the trick is if you get a contradiction, like not G and G, add the or whatever, and then use the other one to do disjunctive syllogism with it.